Hola estudiantes, soy Dora. Vamos a... Oh. Just kidding. Dora's not making an appearance with us today. Neither is her big, huge, unproportional head. Because today we're going to actually be talking about things that are proportional, unlike Dora's big head. So you need your notes for section 3.4, your book if you're using it, that's starting on page 118. You might want a calculator, sticky notes, a pencil obviously, whatever materials you think you'll need. Today we're going to work on writing a proportion. It's actually quite simple. Once you have the information you need, like we do here in this example A table, we're being asked to set up a proportion for the information in this table. You'll notice that this table gives us information about ringtones and their cost in dollars. There are two ways to set up a proportion. We could either use columns or we could use rows. We're first going to use columns. Remember that columns go up and down. So we're going to look at the information we're given in this table and we're going to write in a column that we're being given 2 ringtones for $6. So we're actually just going to write it exactly the way we see it. 2 ringtones for $6. Since we're being told that this is a proportional relationship, we're going to use an equal sign and look at the other column of our table that tells us 3 ringtones. And the cost is unknown, so that's why we're leaving it as X dollars. On this page, we're not actually going to be solving for X. We're just going to leave it exactly like that. I know, totally simple. But then we're being asked to write a proportion with the same information using rows. You'll remember that rows go across, left to right. So we're going to take the information in the table from left to right. We're going to compare 2 ringtones to 3 ringtones. 2 ringtones to 3 ringtones. Which means on the other side of our proportion is where we're going to put the information in dollars. It's very important that you're consistent. Knowing that 2 ringtones goes with $6 and I have 2 ringtones on the top of my proportion here, I need the $6 to be on the top over here. And 3 ringtones is the information that I do not have the dollar amount for. So right across from 3 ringtones is where I'm going to put X dollars. Yep, it's that simple. Look at example B. We're being asked to set up a proportion for the information in this table. You notice that we must be making some sort of soup. Our original recipe calls for 1½ cups of beans and 1 tomato. We want to increase our recipe. Maybe we're having a Super Bowl party, whatever the reason, we want to make more. So I want to use 6 cups of beans. You might not want to have many people over if you're eating 6 cups of beans, just saying. But anyway, if you want to use 6 cups of beans, we have to figure out if we want the recipe to taste the same, then we want to use the same amount of tomatoes just to compensate for the 6 cups of beans that we're using. So we're going to first use columns. Literally look at the column of your data table and we're going to put 1½ cups of beans with 1 tomato and we'll put the 6 cups of beans with our unknown amount of tomato. But it's likely going to be more. Then we're going to write the same proportion using our rows. We're going to take 1½ cups of beans and 6 cups of beans and put them together on this side of the proportion. One and a half cups of beans, 6 cups of beans. That's a lot of beans. Which means we need the information on our tomatoes to be on the other side of our proportion. Remember that since 1½ cups of beans went with 1 tomato, that needs to go on the top of the other proportion. And our unknown number of tomatoes needs to go on the bottom. Oops, sorry, can't see that. And that's it for this section. Mrs. Tremblay and I thought, this is so easy, we can keep going. So if you turn your paper over to our 3.5, this is where you're going to actually be figuring out what that x is. So this is our 3.5. If you're using your book, you'll flip to page 124. When you have a proportion with a missing value, there are 3 methods that can be used to find the missing value, or in this case what that's called is we're solving the proportion. The first way we can use, and if you need to see like a colored version of this example, page 119 in your book. This one's called mental math. You can simply ask yourself what number would make the fractions proportional, because ratios are fractions. I know it's the F word in math. But if we have 3 halves and we want to know how many eighths that would be, this is where you work like you did with the equivalent fractions. When you say, okay, if I want to go from 2 to 8, I multiply by 4. So I would want to do the same thing to the 3. So 3 halves is equal to 12 eighths. And you can use those cross products like you did the other day and double check that your cross products are equal. 24, 24, we know we're okay. Same thing over here, if we use mental math, to get from 5 to 20, again it's times 4. So we do the same thing here, 8 times 4. So 5 eighths is equal to 20 over 8 times 4, 32. Unfortunately, they're not all going to be that perfectly worked out. Sometimes we're going to end up dealing with numbers that aren't as pretty. This is my least favorite method, using multiplication, the multiplication property of equality. This might look a little familiar to you from when we solved equations. We have that 5/7 is equal to x over 21. Remember that the fraction bar is like a division symbol. So here it's like x is being divided by 21. How do you get rid of dividing by 21? Well, you multiply by 21. So if I multiply this side by 21, my 21s go away, and I'm left with just an x over here. On this side, if I multiply by 21, you could type this right into your calculator. 21 times 5/7. Do what you need to do. Type it all in. I'm looking at my cheat sheet. 21 times 5/7 equals 15. So in this case, x is 15. The other side, I'm being told to zoom in. All right. W divided by 6 equals 6 divided by 9. Or W to 6 is as is 6 is to 9. I want to get rid of this dividing by 6, so I'm going to multiply by 6. Remember, once you have that, you get to cross them out, and that's the fun part. So I'm left with just a W equals, multiply the other side by 6, type it in if you need to. You'll notice that what you have on top is 6 times 6, which is 36, and then divide it by 9, you end up with W equals 4. Last one like this. We want to get rid of this 15, so we're going to multiply everything by 15. So I'm left with just an A. Over here, I'm going to multiply the other side by 15. Do your math. Do what you need to do. Of course, this is the one that I didn't work out. That's all right. I'm going to use some simplifying here. I know that 10 and 15 can both be divided by 5. So I end up with 3 times 12 on top, which is 36, divided by 2 is 18. A is 18. All right. This method is my favorite. They're using the cross products property to set up an equation. All right, you'll remember from the other day that if two fractions are truly equivalent, then their cross products will be equal. That means you can multiply diagonally and those products will be equal. So that means if I take 9 times 17, it will be equal to 3 times y. I kind of have issues and I need to always have my variable on the left side. It doesn't matter, but I'm kind of quirky like that. So y times 3 would be written as 3y. Then you need to calculate 9 times 17, which is 153. This should look familiar to you. Now we're trying to solve an equation. What times 3 is 153? Remember, to solve a multiplication problem, we're going to divide. So divide by 3 on both sides. Now the y is alone. We have one y, or just y. Divide the other side by 3. 153 divided by 3 is 51. So y is 51. Next example. Like I said, I got to have that variable on the left. It doesn't really matter. You probably don't have the same issues I have. 12 times y is 12y. 5 times 6 is 30. I need to figure out what times 12 makes 30. You're probably thinking, there isn't anything. That means we're going to end up with a decimal. So to figure this out, I have to divide both sides by 12. So I'm left with 1y